Alright, in this video we are going to talk about ratios and proportions. Let's start off with the scenario. Let's say we have 6 cupcakes and 2 people. The cupcakes actually kind of look like exploding volcanoes, so maybe they need birthday candles. Alright, that doesn't look very good either. But anyway, what we want to do is we want to write down the ratio of cupcakes to people, mathematically. And there are 3 ways that we can do this. One is with a colon, that's 6 colon 2. You read that 6 to 2. You can just write the English word 2 and just write 6 to 2 as a ratio. Or you can say the ratio is 6 to 2 in a fraction. Now typically if we write a ratio as a fraction, we would like to write it in simplest form by reducing it. And the way that we write this fraction in simplest form, I was told to break my numerator and my denominator into prime factors. So 6 can be written as 3 times 2. And the reason we do that is because we can now cancel a 2 from the numerator and a 2 from the denominator. And that leaves us with a 3 over 1. And units are always nice. So this is 3 cupcakes per 1 person. I want to come back to this scenario, but let's look at another scenario first. Let's say in this scenario we're having a party, and this time we have 20 cupcakes, which is great, but at this party we're going to have 10 people attend. I would like to know the ratio of cupcakes to people at this party. Now any of these ways is a nice way to write the ratio of cupcakes to people. In math, of course, we tend to like fractions quite a bit, and if we're dealing with fractions, we like to be able to reduce those fractions to put the ratio in simplest form. If we do that to this fraction, we get 2 cupcakes per person. What's neat about reducing these ratios to simplest form and actually getting a 1 in the denominator is that now we can compare our 2 scenarios. Let's go back up. In our last scenario, we ended up finding out that we had 3 cupcakes per person. And in our party scenario, we found out that we have 2 cupcakes per person. So finding our ratio as a fraction with 1 in the denominator is pretty helpful because we can tell in which scenario we have more cupcakes per person. So just a little vocabulary for you. A unit ratio is a ratio with a 1 in the denominator. And as I said, these are pretty handy ratios because they allow us to compare 2 or more different situations. In this example, we came up with unit ratios of 3 cupcakes per person and 2 cupcakes per person. Of course, you may be asking, what if we had 5 cupcakes and 2 people? This doesn't come out to be a nice round number. You can still do 5 divided by 2, and you'll get 2.5 cupcakes per person in that scenario. Okay, that's a really brief introduction to ratios. You'll talk more about it in class. I want to just talk really briefly now about proportions. This is an example of a proportion right here because we have 2 ratios that are actually equal to each other. 1/2 is equal to 2/4. Now I think that most of you right off the bat know that the ratio 1/2 is equal to the ratio 2/4. But if this were a more complicated problem, how would you test this to see if this was a proportion, if these were equal to each other? Well, what you can do is you can actually find the cross products of this ratio. If you multiply these 2 numbers here, you have 2 times 2, that equals 4. And if you multiply these 2 numbers, that's 1 times 4, that equals 4. So what we can say is, if the cross products are the same, then the ratios are equal to each other, and we have ourselves a proportion. Okay, so you're probably wondering why we're talking about proportions at all. What does this actually mean? What can we do with this? Just as a really quick and simple example, let's say we have a photograph. We have ourselves a little 4 by 6 inch photograph, and we'd like to scale it up. And if possible, you'd like to scale it up to a 10 by 15 inch picture. The question we have to ask is, are these 2 pictures proportional? Because if they're not proportional, we're going to lose part of the original picture when we scale it up to the larger picture. The way that we can test this is with math. The question is a 4 by 6 picture proportional to a 10 by 15 picture? I'll put a little question mark on the equal signs because we're not sure if it's true yet. And the way that we do this, of course, is we find the 2 cross products. We ask the question, is 6 times 10 the same as 4 times 15? And as it turns out, 6 times 10 is 60, and 4 times 15 is 60 as well. So because the 2 cross products of these ratios are equal to each other, we know that these 2 pictures are proportional to one another. What I think is really neat, and this is just kind of a side note for fun, is that we didn't have to write the ratios this way. We could have also asked, is a 4 to 10 ratio equal to a 6 to 15 ratio? And had we asked the question this way, we would have gotten the same result. You take the 2 cross products and you still get 10 times 6 is 60, and 4 times 15 is 60. So there are a couple different ways you can actually set up these ratios to test to see if 2 things are proportional. Okay, so that was really fun. That was just an introduction. Again, you're going to talk more about this in class. For now, I want to get you a video quiz. Okay, so here it is. Find a unit ratio of students per teacher if we have 200 students and 8 teachers. And also as the second problem about proportions, is a 3 by 5 picture proportional to a 4 by 6 picture? Okay, good luck. I'll see you in the next video.